All right, everybody, this is going to be a video over how to graph trig functions. We're going to focus on sine, cosine, and tangent. So let's start off with some vocabulary here. So looking at this picture, we can see that it's going to make this wave shape. And the wave is made up of little cycles. So for example, a cycle is really just a pattern that returns to its original position. So in this case, we start at a peak, we go down, reach the valley, and then we return to the peak. That is one full cycle. Now, the length of this cycle, like how long it takes for it to return to its starting position, this distance here, is something we refer to as the period of the function. Okay, and this is why you hear trig functions a lot of times referred to as periodic functions, because they're made up of cycles, and those cycles have periods. Now, the other thing that we're going to measure is what we call the amplitude. And today we're looking at just the parent function. So the amplitude is going to be half the distance between your minimum or maximum, minimum and maximum, or it's the distance from your midline, which in this case is the x-axis, to your peak or your valley. So how far away the trig function goes away from the x-axis in this case. Okay, and we'll talk a little bit more about this and how it can be changed in the next topic. But our goal today is really just to look at the three basic trig parent functions, sine, cosine, and tangent. And to generate these graphs, we're going to be looking at the unit circle, reading values around the unit circle to help us get some points. Now, the weird thing here is the x-axis is actually representing angle measurements in radians. So think of the angle measurement as our input, it's like our x value, and then the y value at that point is going to be whatever that trig function is equal to at that angle measurement. So for example, if I'm graphing the parent function of sine, y equals sine of theta, I'm going to start at 0 on my unit circle. Right? On the unit circle, sine corresponds to the y value at the point. So at 0 degrees, the y value is 0. So I'm going to plot a point at 0, 0. And then I go to pi over 2. At pi over 2, sine is equal to 1. At pi, sine is equal to 0. 3 pi over 2, it's equal to -1. And at pi, or I'm sorry, 2 pi, we return to 0. So it's going to make this curve shape here, this wave shape. This is one cycle of our sine function. Okay, that cycle is going to repeat in either direction forever and ever and ever. Think of it as just being like copied and pasted to the left and to the right forever. Okay, but this is one cycle of that sine function. Now the amplitude, remember, is how far we go from the x-axis to our maximum, or we can measure to the minimum, it doesn't matter. But for the parent function, the amplitude is always going to be 1. And the period, again, how long it took for it to complete one full cycle, in this case is 2 pi. It's a full revolution around the unit circle, right? On our x-axis, we started at 0, and then we returned to that same place at 2 pi. So the distance there is 2 pi. Now, like I said, once we know the pattern, we can continue it in either direction. I'm out of room on the right, so I'm just going to put my arrow there. But on the left side, I know that my pattern will continue to make this wave shape. So it'll go down, middle, max, and then return. So again, I can continue this pattern to the left. And that's our sine wave. Okay, typically, because sine and cosine are going to look very similar, think of the sine pattern as middle, max, middle, minimum, middle. This is typically how I want you guys to plot your points to get that first cycle down. Okay, so that's our sine parent function. Cosine is going to look very, very similar. We're going to do the same thing. We're going to go along the unit circle and find some values. For cosine, though, it's the x value that we're looking at. So at 0, cosine is equal to 1. And then at pi over 2, it's 0, pi, -1, and so on. So again, I am returning to the same point in my cycle at 2 pi. which is going to make the period 2 pi. The amplitude is also 1. But this is what our cosine cycle looks like. Again, it's starting at the top, middle, minimum, middle, top. So when we're looking at a cycle for cosine, it's going to look more like this shape here. Now I can continue this pattern to the right. It's going to come back down. To the left, we're going to go middle, minimum, middle, and then maximum. So again, we can continue this shape. Okay, so sine and cosine look very, very similar. Their starting points are different. Sine is going to start at 0, cosine is going to start at 1, and complete its cycle or its pattern here. Okay, now tangent's the weird one because tangent has places where it is undefined. Remember, along the unit circle, tangent is the y divided by the x. So anytime I have an x value of 0, my fraction becomes undefined, which means I'm going to have a vertical asymptote at those locations. So those spots where x is 0 are going to be at pi over 2. So I'm going to draw my asymptote here, and 3 pi over 2. Now let's complete the cycle that falls in between these two asymptotes. Okay, so at 90 degrees and 270 degrees, 270 degrees, we have these asymptotes. So we're basically looking at like quadrants 2 and 3 on our unit circle. Okay, the easiest one is probably pi, right? At pi, we have an x value of 1 or negative 1 and a y value of 0. So when I divide, I get a y value or an output of 0. So I've got this point here halfway in between my asymptotes on my midline here or on my x-axis. And then if I go halfway in between pi and 3 pi over 2, right, where we have that reference angle of 45 degrees, my x and y values are the same. So if I divide them, I end up with a positive 1. And halfway between pi over 2 and pi, the same thing happens, but I get a negative 1 instead. This is going to reveal the shape that we're going to see for tangent, where we're riding along the asymptote on the left, we cross through that middle point, and then ride back along the asymptote on the right. Now, for right now, the way I want you to just graph these is I want to see the asymptote sketched. I want to see the point in the middle, and I want to see the curve. I'm not too concerned about you getting additional points. We can get them using the unit circle, but for now, this is just a very basic introduction to it. So I'm okay with you graphing more of a rough sketch. As long as the asymptotes and middle point is there and you've got the right shape for tangent, I'm okay with that. Okay, but just like before, we can continue this cycle and this pattern to the left and to the right. So I'm going to have an asymptote at negative pi over 2, at negative 3 pi over 2. I'm going to have my middle points halfway in between the asymptotes, and then I'm going to have my curve that's cutting through those middle points and riding along the asymptote. So tangent's a weird one. Now, when it comes to amplitude, because it goes up and down forever, we're just going to say the amplitude is undefined, and the period is actually 1 pi. If you measure how far apart the asymptotes are, they are 1 pi apart. So it has a different period than our sine and cosine functions. Now, we can make some generalizations about amplitudes and periods here. Sine and cosine are going to work the same. The amplitude is going to correspond to whatever the absolute value of this A value in front is, and the period's going to be affected by this B value in front of theta inside of sine or cosine. Now, the typical period for sine and cosine is 2 pi, so we're going to adjust this period by dividing the normal period by the absolute value of whatever B is. Now for tangent, we know the amplitude is undefined, so we don't need to worry about that. That's not going to change. But the period can, and where the asymptotes are located can change. Because tangent has a normal period of pi, we're going to start there, and we're going to divide the normal period by the absolute value of b to find the new one. And the asymptotes are going to be located at odd multiples of pi over 2 times the absolute value of b. And the reason it's pi over 2 is because if you look at the graph that we had here, every single one of our asymptotes was located at an odd multiple of pi over 2, like 1 pi over 2, 3 pi over 2. If I kept going to the right, it'd be at 5 pi over 2, and so on. So that's what I mean by odd multiples of pi over 2 times b. So last couple examples here, and then we'll wrap it up. For each one of these, I want to find the period and the amplitude for the function. So for our sine function here, this is our amplitude in front. And then the period, remember we have to take the normal period for sine, which is 2 pi, and divide it by b, which is this 1/3. If I'm dividing by a fraction, I'm really multiplying by the reciprocal. So this period would be 6 pi. And the way I think about it is, if the normal period of sine is 2 pi, like if this is 0 to 2 pi, 6 pi is going to be much more stretched out. It's still going to go the same height, like down and up. I didn't sketch that very well, but it's going to take a lot longer to complete that cycle. Now for the next one, for this cosine problem, again, the 1/2 in front is going to be our amplitude, and then the b value inside is going to affect the period. So we're going to take the normal period of cosine, which is 2 pi, divide it by 5, and we don't even need to simplify that. That would be our new period. Now, going back to my little sketch here, 2 pi over 5 is a much shorter cycle. So if 2 pi is the pink one here, 2 pi over 5 might look more like this, where it's completing that full cycle, that full pattern, much faster than the parent function. Okay. Last example, we've got a tangent one here, so we don't need to worry about amplitude. Remember, the amplitude is always undefined. The period is normally pi, so we're going to take our original period of pi and divide it by this b value of 1/2. Again, if I'm dividing by a fraction, I'm really multiplying by the reciprocal. So this would be a period of 2 pi. And then if I wanted to find my asymptotes, I could use that formula as well. But that's it for this video, just a really basic introductory view of these 3 trig functions. We'll look at them more in depth in the coming days.